Hello, we are starting a new concept today. So we're going from inequalities to something brand new. So in your notebook, you're going to label table of contents with the date today, 12, maybe you're watching it on the 8th, maybe you're watching it on the 9th. So you write in that for yourself. And then this is about ratios. Okay, everything you need to know with ratios, what the heck a ratio is. So let's start off by that exact thing. What is a ratio? So a ratio is just a way to compare two quantities by division. And you'll see ratios in three different ways. So there's one way, writing it out 5 to 7. There's another way, 5 with the 2 dots, 7, or 5 fraction bar 7. And we'd read them as 5 to 7. So a ratio, again, you're comparing two quantities. Okay? So something else that we need to know about ratios is that we can have things that are called equivalent ratios. And that's just two ratios that name the same number. They're the same, they represent the same thing, the same amount. And you can find equivalent ratios by writing a ratio as a fraction and finding an equivalent fraction. So for example, if I have the ratio 6 to 7, what would be an equivalent ratio? Well, they advise writing it as a fraction, like 6 to 7. What would be something equivalent to that, equal to that? Well, if I just double both of these, I'd be at 12 over 14. And 12 over 14 would simplify to 6/7, so these would be known as equivalent ratios. Another example, 8 over 12, an equivalent ratio to that would be to just simplify it. I could divide both by 4, and I could get 2 over 3. So 8 to 12 is the same, meaning the same thing as 2 to 3. Or maybe I didn't want to divide by 4. Maybe I wanted to divide by 2. I'd get 4 over 6. 8 over 12 is equivalent to 4 over 6, which is actually equivalent to 2/3. Equivalent ratios. This one over here, making pancakes. So now I'm relating it to a situation. Let's say you're making pancakes, and for every 2 cups water, you need 3 cups flour. So this is water, this is flour. But let's say you're going to increase that recipe. You want a lot more pancakes. So instead of 3 cups flour, instead of 3 cups, you're going to use 9 cups flour. But you want to keep those pancakes tasting the same. So how much water am I going to need? Well, I'd want to set up an equivalent ratio. So I want something that is still worth 2 to 3. So for me, I'd see 2 to 3. To get from 3 to 9, I'd multiply by 3. So to get from 2 to this question mark number, I'm going to multiply that by 3. So I would need 6 cups of water. So 6 to 9 would be an equivalent ratio of 2 to 3. So 9 cups flour, I'm going to use 6 cups water. Not 2 cups water, because then it's going to be gross. Okay, let's go ahead and try 2 problems here. Try them out. We're going to try to analyze an error made in this situation. So let's say your math class includes 15 girls and 10 boys. Right when I see this, I see a ratio. And I even see, kind of if I speed ahead in the reading, it says the ratio of girls to boys. So I'm going to write out the ratio of girls to boys. And what do I have? I have 15 girls to 10 boys in my math class. 2 new students, a girl and a boy, join the class. Your friend says this ratio is the same as before. And then it says explain your friend's error. So your friend must be wrong. But if a new girl comes into the class, It's not going to be 15 anymore, it's going to be 16. And a new boy comes in, it's going to be 11. And your friend is saying that these ratios mean the same thing. They're the same. They're equivalent ratios. So in order to compare them, I'm going to write them as fractions. 15 to 10, is that equal to 16 to 11? Well, for me, I'm going to actually divide and get that number. So you guys feel free to use a calculator in these problems. 15 divided by 10. I'm going to use my calculator. And I'm at 15 divided by 10 is 1.5. So I'm going to write that in. So this one is 1.5. And is that the same as 16 divided by 11? Again, divide it out. 16 divided by 11. 1.45, repeating. 1.45 with the 4 and the 5 repeating. So those are not the same. So no, these ratios are not the same. Because when we divided, they weren't the same number. So the ratio of boys to girls is not the same. Okay, let's look at one more. Something about an official U.S. flag. I have one up in my classroom. It actually has a certain ratio happening if it's an official U.S. flag. It has a length to width ratio of 19 to 10. Length to width. The largest U.S. flag measures 505 feet by 255 feet. Is this an official U.S. flag? So is it equivalent to the 19 to 10 ratio? So again, I'm going to compare it with fractions. Is 19 to 10 equivalent to 505 to 255? Feel free to go ahead and use the calculator, but I know 19 divided by 10 is 1.9. If you don't agree with me, then I will check it on the calculator for you. 19 divided by 10, 1.9. And then I'm going to check the other ratio, which was 505 divided by 255. And that is 1.98 approximately. Okay, so this one keeps going onward, but I stopped at the 100th spot to notice that it is different. They're very, very close, but still not the same. So I would say the largest flag is not an official U.S. flag. Okay, so be ready in class to look at ratios and ratios that are equivalent and not equivalent. See you then.